So no one on YouTube seems to really understand light and how light works. Light is just an electron changing energy states. What you don't realize is that when they were making these measurements with these really old technologies, they weren't capturing the whole picture. So if you see an electron, right, and it's moving like this from this perspective, it's going to look like a sine wave. If you take it from a different angle, it's going to look like a point, especially if it collides. So when it collides into a sensor, it's like, oh, it's just one point. But when you look at it from the side, it looks like a sine wave. But you don't realize that's at the speed of light to accurately acquisition even a meter's worth of resolution. And I said this before. This is how many seconds you have to measure it if you wanted to accurately measure about a meter, right? And so to get it down to a centimeter, that's what the bottom one is, right? An extra 2 zeros. We didn't have technology that could acquisition data that fast. Here's another way that I've shown it, right? So what you're seeing there is like the light that we don't see. Understand that your phone, your screen, whether or not it's in your computer, is able to display about I think we can see about 10,000 or 10 million colors. And the screen can display like 16 million, but the lens itself can pick up even more. So what you're looking at here is actually a super slow-mo of just my hand. That's the edge of a drum stool, a little piece of aluminum foil, and a pen in my hand. And you'll see how they're reflecting or absorbing light, how that shadow is actually being removed and one's being cast there. And this is all light that's coming through the power grid. This is actually the 60 hertz, 120 volt AC that we see. I just had a surge protector with a lot of power going through it, and I just super slow-mo recorded it. This is just me getting that same signal through a different means. What I'm doing is taking a little loop of wire. It's basically a Faraday. I just spliced the wire together and made a loop. And what it's doing is that energy that I'm picking up on that little oscilloscope, I think it's like $40 on Amazon. That oscilloscope is reading the actual intensity and it's being turned into heat. This is now me super slow-mo recording it as well. So now you're seeing the shadows that it's casting as it's turning that into heat. I recommend you put that in 4K, or well, actually, I think it's only up to 720p anyway. And then super slow-mo, pause it at different times and see how it's casting shadows. It looks a little grainy, but I'll actually show you how to reproduce this with your phone. I'll show you how to reproduce it with an Android. All right, what I'm showing you here is some pulse width modulation. This is what happens when you turn a light on and off, or even a device like a motor on and off a set period of time to reduce the average power without actually having to burn off that extra power. If somebody comes on here and says anything about rolling shutter effect, please, if you understand anything about the hardware that's here, you understand that rolling shutter effect is the exact opposite. Rolling shutter effect is when your refresh rate on the camera is too slow to pick up what's there, and so it's appearing in other places. What we're showing you here is the opposite, and where the camera refresh rate, and I'll show you how to reproduce it, is high enough that you can actually acquisition the data. This shows you here that when the light's moving towards you, it's more of a white color. When the light is moving away from you, it's actually more of a yellow color, and you can see the angles and how that actually. But understand right now that those bars, I don't want to get into time-space curvature, but that's an example of the time-space curvature when you're looking at things from different perspectives from an update coordinate system. Now, the first things first is you're going to have to save raw copies. So if you look in your settings here, you probably won't see it, but what you need to do is you go over to the Pro, right? So we'll go over to More. We'll go over to Pro. And these are the old settings we have here. If we go over to the settings here, we can go to picture formats, and you'll see you have to save yourself a raw copy. If you don't save a raw copy of it, then it's going to be edited. It's going to be compressed. So all that information, all that colorful stuff that in the background that looks like it's just blurry nonsense, understand that that is actual reality. Someone might show up and be like, oh, that's just some artifacts. Artifacts. You mean information, aka energy, that is literally hitting the sensor, because the sensor itself literally can't be triggered unless information or energy hits it. It literally can't be triggered. And the fact that it's distinct colors and you can distinguish the dark from the light, the fact that it's reproducible across other cameras, the fact that they literally compress to remove that information, that's reality. Just think about the fact that we know it's mostly empty space. We know that this might look solid, but it's just a crystal lattice. We also know that colors don't really exist. It's just energy. All of this is inside of our head that we're seeing is just a mental model of reality. It's not really reality. I believe I already did this on a video before, but I'll show you here. So what we're going to do now is we're going to go to a Pro Video or Pro Camera mode. And as you can see, as we have the speed higher, the bars get thicker because the average light, we get this thing called the, not called the rolling shutter effect. Okay, what happens is this is the opposite. This is where the lens is actually so fast it's picking up the screen as it's refreshing, but it has to model that, and the screen that I'm looking at right now that I'm recording doesn't have the ability to reproduce data that quickly. So what it does is it shows that average on, that average off time as black bars. And so you can see it as you rotate it here, the bars will change. Right now, it's not coming out as good because the speed isn't as high, because as the speed gets higher, it gets darker. And right now I have a certain, right now it's too bright in the room for you to get that. So this is that there. And so as you can see right now, the screen looks different, but if we go ahead and adjust this up brighter, get that speed going here, we'll start to see the bars appear as I adjust this camera lens speed. And it's just doing basically like an average of what it's seeing on the screen. And this is kind of how we get that average too. Here's super slow-mo on some other things. TV, got some Dr. House there. And when we come back, give it some time. And then that's what it looks like in super slow-mo. That's the screen going on and off. See if we super slow-mo this one here. See what that looks like. I should have probably flipped it. That camera probably would have been the better one to use here. But regardless, this is just the Galaxy Note 10 Plus. So it's like a 2019 cell phone. Definitely something that you can reproduce. And so here's the bars here on super slow-mo. Yep, see? Something you can reproduce yourself with just a regular camera phone. Well, you might not be able to do it with Apple, and that's just because they don't give you the settings. It's not because the hardware can't do it. The Apple hardware, the cameras that they have, they should be totally capable of doing this. It's just the software. They just won't let you do it on the software, so go bitch to them. So for that little Faraday loop, for that one, it's just a wire, like I said, like this. Basically, you know, you just take the wire ends, you splice them. Basically, if I put it together like this would technically be a loop around my neck the same way. And so you just do like that. You find yourself a power cable like that. That was just for that the same light that was doing the thing. I just used that light in front of there so you could see it.